Welcome to Networks Professionals.
All right, let's jump right into this explainer. Today, we're tearing down the invisible mechanics that literally keep our hyper-connected networks from collapsing into one giant digital traffic jam. We're talking about demystifying the total unsung hero of network engineering, quality of service, or QoS. We've got some great stuff to cover, so let's just get to it.
So why do critical video calls fail exactly when you need them most? We've all been there, right? Picture this. You're mid-pitch to a vital client, or maybe finally catching up with family halfway across the world, and boom, your face freezes in some incredibly awkward expression. The audio completely cuts out, or the whole stream just drops. It's so frustrating. But it's actually not just random bad luck. There are very specific, kind of nasty technical villains causing those agonizing delays.
Which brings us to our first section, the digital traffic jam. Let's quickly look at the three main culprits.
Villain number one is latency, basically the delay in data transfer. Think of our network like a sprawling multi-lane highway. Well, latency is your slow, agonizing morning commute. It's just the physical time it takes for your data to travel from point A to point B. During a real-time conversation, this is exactly what causes that super awkward pause where you and the other person end up talking over each other over and over, all because the data just took a fraction of a second too long to arrive.
Next up, we have packet loss. This is exactly what it sounds like. Data completely failing to reach its destination. Imagine if, during rush hour, a few random cars just vanished off the road. Poof, gone. In networking, your data is chopped up into tiny little vehicles called packets. So, in a VoIP call, packet loss means actual pieces of your conversation are dropping straight into the digital void. You hear, "Let's meet at," and then dead silence. That crucial piece of info, it literally never arrived. And the third culprit is jitter. This is all about inconsistent delays that cause that incredibly choppy audio or video. So if latency is a slow commute, jitter is a commute where you're constantly slamming on the brakes, then hitting the gas, then the brakes again. The data packets are arriving for sure, but their timing is completely erratic. This is what turns your super important voice and video calls into, malfunctioning robots and weird stop-motion animations. All right, moving on to section 2. What exactly is QoS? Okay, so if the network is a super crowded, chaotic nightclub, we desperately need a way to make sure the VIPs can walk straight through the front door without waiting in line with everybody else. Enter quality of service. QoS is the absolute hero here. It acts as a digital bouncer, aggressively fighting off latency, packet loss, and jitter to actually take control of the chaos. Strictly speaking, quality of service, or QoS, is a protocol that manages network traffic to prioritize critical applications like voice and video. By actively tagging, classifying, and queuing data, it stops non-essential background traffic from getting in the way of your highly time-sensitive packets. It ensures high-quality performance even when the network is totally jammed up. Honestly, it's the ultimate traffic cop. To put this in perspective, just consider the difference between high-priority traffic, like a live VoIP video call, and low-priority traffic, like a massive background file download. I mean, a software update can take a few extra minutes, right? Nobody gets hurt. But if that massive download is treated exactly the same as your boss's crucial video call, it's going to completely clog the highway and crash the meeting. QoS steps in to make sure the call gets the absolute fast lane, while the download takes the scenic road. Let's move right along to section 3. How QoS prioritizes traffic. So how does it actually clear the path? Well, it happens in 3 distinct steps. Step 1 is classification and tagging. The system acts like an inspector, figuring out what type of data is in each packet, like, oh hey, there's a VoIP packet, and then literally slapping a VIP priority tag on it. Step 2 is queuing. The network takes that tag data and shoves it into faster, dedicated queues. Think of it like opening up an exclusive express checkout lane at the grocery store just for those VIP packets. And finally, step 3 is traffic shaping. This manages the overall bandwidth by physically throttling that low-priority traffic so we can absolutely never monopolize the network. Which brings us to our final section, the real-world impact. So what's the actual takeaway here? Because of these behind-the-scenes mechanics, we get massively reduced latency, which is absolutely critical for guaranteeing clear, real-time calls. It ensures consistent performance for your business apps. It completely optimizes network resources, so bandwidth isn't just wasted on nonsense, and it actively avoids the bottlenecks that cause those digital traffic jams in the first place. To really cement this idea, there was a great point made in a recent May 2025 YouTube explainer by Code Lucky. They noted,
QoS provides consistent performance for critical business applications and optimizes network resources to avoid bottlenecks. And they hit the nail on the head. Whether you're just a casual internet user at home or you're running a massive enterprise, QoS is an absolutely essential pillar of modern infrastructure. Without it, the sheer congestion would just overwhelm us.
As we wrap up this explainer, I really want to leave you with a provocative thought. As we connect more devices than ever before, smartphones, smart cars, home appliances, remote servers, the whole shebang, who actually decides what network traffic matters most? Quality of service gives us the amazing tools to prioritize things today, but as our digital highways become infinitely more crowded, the debate over who really gets that VIP lane, that's only going to get way more complex. Thanks so much for joining me to explore QoS, and I'll see you in the next explainer.
Thanks for watching.